I purchased and reviewed the Osram LEDVANCE 20-watt LED downlight quite a while ago, and I've been meaning to tear down the device ever since really, but I've used it as a bit of a video background light from time to time, especially before I came up with some other lighting systems. But anyway, today I'm going to be taking it apart. Now, also in this video is going to be about the first time I've tried doing two simultaneous camera angles sort of at once in a video. So that's going to be interesting. So if I just plug the lamp in, I've just got attached a bit of flex. But you can see that it has a really rather nice kind of light. So it's 4000 degrees Kelvin and the colour rendering is about 80. So it's about as good as a triphosphorescent. Now, this is rated to about 1000 lumens and it does seem to emit that much, and it has a beam angle of 60 degrees while consuming 20 watts of electricity, and it does actually indeed use that much. Now, as is common with these LED downlights, you can see it has these orange clips to fit onto a ceiling, and you can just see some information on the top of the unit there. So if I just disconnect it here, then we can open it up and see what's inside. Now, this unit had a sort of what I thought was actually a rivet to begin with, but it's actually a sort of very, very small sort of Allen key screw at the top middle, which you can just see there. Now, I didn't notice at the time, so I kind of forcibly found my way into the device. And there are also these screws just to gain access to the sort of wiring connector in the unit as well, which also help hold the top down. So if I just slip that out, just undo these screws there, they a bit of a fight, but if I just take that out, so you can see now there's a Wago connector at the bottom inside. So as you can see, I've just got a bit of flex in it just to test it out, and obviously as with common with Wagos, you just squeeze those down and the wires come straight out. Now, as I've removed the screw from the top of the unit there, I can then just pop the lid off and we can see the circuit board inside. Now, this has quite a nice circuit board inside it, which, yeah, it looks very good quality actually. I was quite surprised, and it stays quite cool as well, which is perhaps helped by the fact that it is mounted on a nice sort of plastic insulating layer there. So in terms of what the actual circuit looks like, I've sort of partly drawn a diagram of it, and this has quite a large amount of sort of input filtering before it hits the actual sort of power modifying circuitry that then feed the transformer and the LED. So there's quite a lot of inductors and capacitors there to sort of smooth out the input voltage and to try and prevent interference from the sort of switch mode design that is typically used feeding back into the mains. Now, the reason I haven't done a full schematic for this is that the IC on the back of the unit is not, I have not been able to find any information for that chip there. So that obviously makes drawing a circuit diagram rather difficult. And the only other sort of modifying sort of component is the MOSFET, which is mounted on a heatsink there. But apart from that, the circuit board doesn't have really all that much on it really, and furthermore, actually, there are clear signs that they have taken steps to sort of keep spacings sufficiently far that there won't be any crossover. So that's all very nice, and like I said, since the power supply runs quite cool and actually the components look to be quite good quality, this will most likely be able to survive for about its 50,000 hour rated life, which is quite nice. Now, the final thing to note, if we just lift the board up here, we can see there's a cable which is connected to the PCB, which then goes through the heatsink to most likely the LED module mounted on the heatsink further down. But to gain access to that LED module, we have to sort of gain our way into the heatsink. The front cover easily twists off, and this front cover is pretty simple, so it's just really a metal metal sort of surround, which is quite nice, white painted, and then a bit of glass stuck around a middle hole there. And this glass does have quite a nice colour when you sort of flip it around, presumably so if you're looking underneath the unit with that mounted on, you get quite a nice high-end appearance to it. We'll just put that to the side now. So you can see now on the bottom of this that there are a number of screws holding something on, most likely this front cover here. So if I just undo those now. So now that I've undone all of those screws, the cover comes off quite nicely here, and you can see that it just fits into the sort of mould, the sort of shape of the heatsink quite nicely. And also to note, there are these little orange sort of slips that fit on the underside of the heatsink just to give this a sort of more professional appearance. So now that that cover's removed, it's possible to see that there is a sort of slight bridging across the front, and that's used to most likely hold the front lens compartment, and there we go, it does indeed. So we just take a look here at this, so we can see that there is the sort of diffuse layer at the front with a sort of focusing sort of enlargement section there, which will be sort of aiming the light for the 50-degree beam, and then there is also a very nice reflector there to again reflect the light from the LED array. So if I just bring this light towards the camera, so you can see the red and black wires from the sort of power supply, which then feeds onto a PCB, which is of the typical design. And then on the PCB there is a 3, 4, 4 and 3 LED arrays, so in total there 14 LEDs, so each one will be just over about a watt in power. And these have got quite a nice sort of phosphor coat on them, which is quite a nice vibrant sort of orangey yellow colour, which will be converting those violets into the red and orange, and therefore providing the good sort of colour rendering index of this lamp. Now there are a few sort of resistors on the board, but they all appear to be relatively low value, and I can't quite identify what they are for currently. But I think it would be a good idea to undo these screws and see what that then sort of releases of this product. Now, like I said, there are a lot of screws on this lamp. So now I decided to undo the large screws on this first, and that then just enables this sort of black insulating layer between the heatsink and the PCB to come undone. And actually, now that all the sort of components have been removed, it's possible to see this is actually quite a large sort of heatsink block, and it is actually really quite weighty. You know, this is proper sort of thick metal, and certainly not like the cheaper LED products that you get on the market. Very, very nice. Now there's just all these smaller screws on there, which I can probably safely assume are just holding the LED board on, which would lead to a very, very good sort of mechanical strength on the board and ensure a good sort of connectivity thermal wise to the heatsink to dissipate the heat. And in fact, actually just looking at the PCB around the LEDs in detail, so I'll just bring the camera up close here, it's possible to see that actually the resistors are mostly in place of where LEDs are sort of missing on the board. So the two missing LEDs there appear to be represented by resistors. And in fact, you can actually see on the top of the PCB there instructions on how to sort of wire the sort of resistors and diode positions on this PCB in order to allow for the different configurations of the unit, presumably for the different sort of wattages. So that does kind of helpfully confirm that the sort of spare LEDs, the spare LED sort of solder positions being replaced by resistors as a conclusion of this. So all in all, actually a very nice LED downlight. and you would possibly expect it because these were really not cheap at the time at all, although I got mine rather cheap from an online auction site. And actually, just before we sort of end the video, just show you the PCB in a bit more detail, seeing as it's no longer sort of tethered to the heatsink. So you can see it is a nice layout on the board, nice component spacing, and like I said, thermally quite well managed, although presumably the MOSFET there does get reasonably warm based on the fact that it has a heatsink on it. But aside from that though, as we can see, quite big diodes there, and I mean this is going to be producing about 20 watts of power, so that is a reasonable current. And the capacitors on the output side are rated at 63 volts. Although as this video has got quite long already, I'm going to perhaps do a second video hooking this up to an oscilloscope and looking a little bit more at the voltage and sort of power performance of the unit. So I hope you've enjoyed a look inside a professional, well-built, quality LED lighting product. Now, I can understand, having shot this video mostly with the two cameras, why a lot of people who tear down products on YouTube don't generally use two cameras for the filming process, because trying to look at the camera, face the camera, talk to the camera, while also looking at what you're sort of tearing down, what you're taking apart, while also operating another camera, is basically impossible to do. And hence why at times I was not looking straight at the camera and was looking at either the other camera to my side or the item I was already taking apart or using. So I'll perhaps have to perfect the way that I do that in future videos. The best thing to do will probably be to feed the output from the second camera into a screen in front of me rather than to my side, so at least that way I'm looking more to the front. Also, I realised that my keyboard has a lot of the letters kind of not existing on it. I'm just kind of trying to see how long the keyboard will actually last, and obviously an awful lot has been typed on that over the years. So thanks for watching, and I'll see you on the next video.